Welding steel submerged in ocean water defies the basic principles of thermodynamics and electricity, an engineering paradox that underpins vast submerged infrastructure. This extreme task forms the core of the second episode of the Abyss Profession, the industrial underwater welding podcast series, which explores the rigorous standards governing this challenging field.
That's right. No one becomes an underwater welder through improvisation. In the maritime and offshore industrial market, work adheres to rigorous international technical rules. When a student takes their final exam, the fundamental standard determining their operational qualification is UNI EN ISO 15618-1, the absolute pillar of wet underwater welding. To understand the market, we first need to map the international regulations, which are divided into two clearly separated approaches. UNI EN ISO 15618-1 qualifies the welder for direct action in water, known as wet welding, where the operator and the arc are in direct contact with the liquid. In contrast, UNI EN ISO 15618-2 refers to dry hyperbaric welding, performed inside protected structures called habitats.
Looking back, when offshore construction began, the only repair option for hulls or pipelines was the dry dock, a slow, expensive, and impractical method for fixed infrastructure. The oil industry's push into deeper waters in the 1960s created an urgent need for on-site intervention, so engineers initially focused on Part 2, right?
Precisely. They would lower huge bells or sealed habitats to the seabed, pump out the water, and inject breathable gas mixtures, allowing technicians to weld in dry conditions, almost replicating a land-based workshop. From a purely metallurgical perspective, this approach offers superior mechanical guarantees. Creating an artificial, pressurized gas bubble around the joint eliminated chemical interferences from hydrogen and prevented thermal shock to the molten metal.
On paper, Part 2 sounds like the superior choice. If it offers such metallurgical benefits, why has the global market relegated it to a marginal role, overwhelmingly preferring the wet welding of Part 1?
The answer lies in logistical obstacles and prohibitive financial barriers. Setting up these habitats requires support vessels of considerable size, heavy lifting cranes, and complex, redundant, hyperbaric life support systems. It also demands weeks of engineering preparation to seal the habitat around an irregular pipeline or an encrusted pillar. Operating costs quickly escalate to hundreds of thousands of dollars for each single day on the construction site.
So, UNI EN ISO 15618-1 wet welding offers the supreme advantage of immediate operational and economic flexibility in contrast. The underwater welder descends into the water with only an insulated torch and an umbilical cable, ready to intervene instantly on ships, port docks, dams, or water pipelines. This drastically cuts costs and solves problems within hours of an emergency call.
Yes, but the disadvantage of Part 1 is solely linked to its immense technical difficulty. This flexibility transfers the entire weight of structural reliability onto the manual skills of the individual operator. The professional must manage an electric arc reaching thousands of degrees, which generates a violent cloud of gas bubbles as it vaporizes the surrounding salt water. These bubbles obscure the view almost completely, while hydrostatic pressure compresses the arc, altering its stability. The violent cooling also risks vitrifying the weld bead, making the steel brittle.
It sounds like an incredibly demanding skill. The wet technique requires keeping the electrode pressed against the joint at a strictly constant angle and mechanical pressure. This controlled friction creates a tiny gas microbubble, self-produced by the combustion of the waterproof coating of the electrode itself, which isolates the fusion bath for fractions of a second. This allows the liquid metal to bond with the base material before the ocean freezes it solid. So the manual skill involves anticipating currents and compensating for blindness, relying on the sound of the arc frying underwater and the tactile feedback of vibrations. The professional does not look at the weld, they feel it forming.
Exactly. Whoever passes part 1 is truly a complete professional. It's about skill without laboratory bureaucracy. A common mistake is to think that an underwater welder's exam involves sending pieces to external metallurgical laboratories for X-ray or radiographic examinations. That kind of inspection bureaucracy belongs exclusively to the mainland. Applying laboratory radiographic diagnostics to every single maritime intervention demonstrates a poor understanding of construction site dynamics. Waiting for results would block cargo ships or extraction platforms, generating extremely serious economic losses for every hour of technical downtime.
So, the UNI-EN ISO 15618-1 standard does not reduce safety, it adapts it to the merciless reality of the marine environment, putting the pure skill of the welder back at the center through direct practical verifications on the specimen just extracted from the water. For instance, a direct visual examination on the dock immediately assesses the weld bead geometry for regularity, correct fusion of edges, and absence of surface porosity, demonstrating mastery of the arc despite turbulence. And then there are field mechanical tests.
Yes, immediate destructive cold bending tests, often to a tight U shape, and fracture tests using a hydraulic press are performed. These find internal weaknesses like hydrogen embrittlement or slag inclusions. If the sample resists extreme deformation without tearing, the tightness is validated. CEDIFOP training in the port of Palermo aims precisely at this, to train and forge the diver's hand to create a solid, effective joint capable of overcoming the severe practical barriers of UN-EN ISO 15618-1. The goal isn't to pass a workshop radiographic plate, but to guarantee safety and structural tightness directly in the heart of the sea.
However, knowing how to weld isn't enough. Focusing exclusively on manual skills risks obscuring the fundamentals of survival. The welding technique is nothing if it isn't supported by safety and professional diving procedures that protect the operator's life. One must be able to go into the water in total compliance with commercial diver standards.
For this reason, CEDIFOP has structured a unique path combining underwater welding training with the international IDSA Level 2 qualification from the International Diving Schools Association. This standard of excellence requires abandoning self-contained SCUBA equipment typical of recreational diving in favour of surface-supplied systems from the surface, which is the true pillar of industrial work.
The switch to surface-supplied mode radically alters the dynamic. The operator receives breathing gas, voice communications, electrical power, and hot water for the suit through an umbilical cord managed by a team on the ship's deck. This level of interdependence transforms the diver from an isolated individual into the executive terminal of a complex engineering system. This superstructure becomes essential when considering the risk of lethal electrocution faced when handling high amperage direct currents in an electrolytic fluid like seawater.
Exactly. Current management requires obsessive isolation protocols. The welding circuit is kept inactive from the surface and activated via a knife switch only when the diver vocally communicates they are ready for ignition. Thanks to this inseparable combination, The welder's license joins the minimum access requirements for the inshore level, raising market safety to the highest levels.
This integrated path guides the student to the fundamental formal and legal milestone, registration in the Telematic Registry of Industrial Diving established at the Department of Family, Social Policies and Labour of the Sicilian region.
Being included in this official list represents the true passport of legality for starting work in maritime shipyards and construction sites. It certifies to companies and authorities that you possess both the executive skills of the ISO standard and the constrained diving hours required by IDSA standards. It proves that you are not just welders, but professional commercial divers, recognized by law.
The constant tension between metallurgical perfection of dry habitats and the brutal operational effectiveness of wet welding illustrates the pragmatic nature of offshore engineering. International directives and regional registries do not reward abstract theory, but recognize those who succeed in bending the laws of physics to the needs of the market in extreme environments, all while keeping the human safety chain intact.
Overcoming these practical tests in the darkness of ports constitutes the definitive maturity exam for these professionals of the sea. If you found interesting insights in this analysis of submerged infrastructures and industrial standards, share this episode with a friend or colleague. See you in the next episode of Professione Abisi.